Hello all, hope you all are doing good. In today's session, we are going to discuss different types of decomposition, namely lossless decomposition and lossy decomposition. So this is a representation of the decomposition and its types, that is lossless decomposition and lossy decomposition. Firstly, let us see what is lossless decomposition. The process in which where we can regain the original relation R with the help of joins from the multiple relations formed after the decomposition. And this process is termed as lossless decomposition. Before knowing what is lossless decomposition, let us recall the definition of decomposition. Decomposition is dividing or breaking down the larger relation into several smaller relations is known as decomposition. The purpose of decomposing a table is to normalize the data in the database in order to organize the data properly in the database and also to reduce the problems caused by redundancy. The concept of decomposition has been introduced. Let me take an example over here. Let R be a relation with the attributes A, B, and C and assume that it is decomposed into R1 and R2. Let R1 contain attributes like A and B and R2 contains attributes like B and C. Now, when these R1 and R2 are combined together using a union operation, that is R1 union R2, or when you perform a natural join between R1 and R2, then you will be getting a resultant relation. Let us consider the resultant relation be R dash. And this R dash, if it contains the attributes like A, B, and C, which is similar to the attributes that are present in the original relation, then we can simply conclude that R dash is equal to R, which means you have obtained a resultant relation which is exactly the same as the original relation. So this kind of decomposition is said to be a lossless decomposition. And coming to lossy decomposition, as the name suggests, lossy decomposition means when we perform a join operation on the sub-relations, it does not result to the same relation which was decomposed. After the join operation, we always found some extraneous tuples, and these extra tuples generates difficulty for the user to identify the original tuples. R1 and R2 together, after it is reconstructed, we may not be able to get the original relation R because these relations R1 and R2 in turn contains several extra tuples. Thereby, it creates some difficulty for the user in order to identify which one is the original relation. Now let us learn lossless decomposition with an example. Here we have an example, that is R is a relation which contains attributes like A, B, and C, and this is decomposed into smaller relations, say R1 and R2, with the attributes A and B for R1, B and C for R2. Assume that these are the values which a user has been given for the attributes A, B, and C. Now, once this is broken down into R1 and R2, as R1 contains A and B attributes, the values from the original relation is copied as it is to the smaller relation R1, as well as the values for B and C from the original relation are copied to the relation R2. Now, when can you say that the decomposition is lossless? If and only if when you perform R1 union R2. Now let us find the resultant set for R1 union R2. So here I am going to take down the resultant set. So R1 and R2 contains what? It contains attributes like A, B, and C. So I am taking A, B, and C. When union operation is used, it is going to retrieve only the unique values from the attributes A, B, and C. So firstly, let us write down what all the values that we have under A. Here I have 12, 10, and 12. Now coming to B, in relation R, we have attribute B, as well as in relation R2, we have attribute B. Now, As these values are not to be duplicated, when union operation is used, only once the value for the B column will be taken in our resultant set. So here I am going to take down 25, 36 and 42. No duplicate values will be repeated again for this attribute B. And what is C? Under C, we have values like 34, 9 and 30. So this is our resultant set which we have obtained from R1 and R2. So when union operation is performed between R1 and R2, if we are able to reconstruct the original relation R, then you can say that the decomposition made for R with the attributes A, B for relation R1, B, C for relation R2 is a lossless decomposition. Now we'll see the example for lossy decomposition. Let R be a relation with several set of attributes like A, B, and C. I'm going to draw a table for the relation R. And here we have the attributes like A, B, and C. And there are several values that we will be giving for the attributes A, B, and C. That is 1, 2, and 3. Let here be 2, 2, and 3. And here I'm going to take 1, 2, and 2. So this is my original relation R. Now I'm breaking this relation into R1 and R2. Let us suppose that R1 contains attributes like A and B and R2 contains attributes like B and C. Now I'm drawing the table for R1 and R2 relations. As R1 contains attributes A and B, we are going to take the values for A and B columns from the original table R. So here I get 1, 2, 3, 2, 2, 3. And for R2, we have attributes like B and C. We take the values from the original relation R. So for B, we get 2, 2, 3. And here we have 1, 2, and 2. Now, to know whether this is a lossy decomposition or a lossless decomposition, it is necessary to perform a natural join operation between R1 and R2. So this is the symbol which you use for the natural join operation, right? Now, natural join is nothing but what? It is a cross product between the relations. Now let us perform a natural join operation between R1 and R2 and check whether there exists any values for the common attribute, that is B, which is common in both the relations R1 and R2 are same or different. If the values are different for the common attribute, then that will be rejected in our resultant relation. Thereby it takes only the values that are common. Under A and B, you get 1 and 2. And this is multiplied or it is cross product with the tuples that are present in R2. So here you get what? 2 and 1. Next, 1 and 2, the same row with the second row in the second relation, that is 2, 2. First row under first relation with the third row. Now what it is said? Under common attribute, that is B, whichever are the values that are different, that will not be in our resultant relation. Now let us check one by one. Here you have the common attribute. Here also there is a common attribute. But here when it comes, here that it is 2 and here it is 3. So thereby this particular tuple will not be retrieved in our resultant relation. Similarly, you have to check for 2 and 3. So there is no common value for the common attribute. And here also we have 3 and 2. This is again in not same. 3, 2. This is again not same. So here totally 4 tuples are different. So thereby they are not in our resultant set. Now let us find out what is our resultant set. So resultant set contains only the attributes A, B, and C because we are taking only the common values under B column. So here under A we have 1 and under B we have 2 and C we have 1. And similarly, this is over. And next we are working with this one. 1, 2, 2 we have. And next coming to this one. Under A we have 2, under B we have 2, under C we have 1. And next we have this one, 2, 2 and 2, right? And the last one which we have is 3, 3 and 2, 3, 3 and 2. So this is what is our resultant relation. Now the thing is, whichever resultant relation we have, let us name it as R dash and check whether the tuples that are present in R dash is equal to the tuples that are present in the original relation R. Here we have only 3 tuples, but in R dash you have extraneous tuples. There are 5 tuples. So which can be a lossy decomposition. You might say that if there are extra tuples, how it can be a lossy decomposition. Here there are 1 to 1 and here also we have 1 to 1. Here there is triple 2, here also we have 2 to 2. Here there is 3 3 2, here also there is 3 3 2. As we have the same tuples that are present in the original relation R. Along with that, we are having some extra tuples. So which means this duplication of data will lead to what? Inconsistency of data. So as we are facing with the inconsistency problems, we can say that the decomposition made for the original relation, that is R1 and R2, is a lossy decomposition. Hope you have understood the example of lossy decomposition.